The Earth is a fire planet. Its terrain is covered with combustible organic fuels that accumulate over time and can ignite when lightning strikes. Early Americans used fire for hunting, concentrating prey, encouraging fruit and berry production, to keep the woods open for travel, to clear the land for agriculture, and to fireproof their villages. Whether ignited by lightning or by Native Americans, these fires were a major ecological process that shaped North American plant and animal communities. Fires of varying frequency, intensity, and severity created a mosaic of habitat conditions across the landscape. In some areas, frequent, low-intensity fires maintained open, park-like forests with a diverse understory of grasses, forbs, and shrubs. Examples of these areas would include Piedmont prairies and longleaf pine wiregrass forests. Occasionally, less frequent but more intense fires drastically altered the vegetation, sometimes even killing overstory trees. These types of fires favored Table Mountain pine on western North Carolina ridgetops or Atlantic white cedar in the eastern North Carolina coastal plain. Because of the widespread and frequent occurrence of fire in the southeastern United States, the plants and animals of this region developed characteristics that increase their chances of survival in the presence of fire. For example, some pine and oak species have thick bark to insulate the living cambium from the surface heat. Moreover, Table Mountain pine and pitch pine have serotinous cones that require fire to open the cone and release the seeds inside. Many oaks have early root development that protects buds below ground and allows them to persist even after a fire burns through. Longleaf pine has a grass stage with a thick sheath of moisture-rich needles that protects the terminal bud from overheating. However, in the absence of fire, these plant species are often outcompeted by less fire-tolerant plants, including red maple, yellow poplar, and rhododendron. Similar to plants, many wildlife species in the southeast depend on fire to maintain desirable habitat conditions. Frequent fire may be used to maintain early succession vegetation required by northern bobwhite for nesting and cover from predators. Red-cockaded woodpecker, box squirrels, and Bachman sparrows require the open forests and the dense herbaceous layer maintained by frequent fire in the longleaf pine ecosystem. Hence, without appropriate fire application, these wildlife species decline in number and even go extinct locally. Wildlife mortality during fires is relatively rare, although it does occur for some species. Most animal species have adaptations that limit fire-induced mortality. Birds can fly away. Larger mammals run to escape approaching fires, and small animals like mice, salamanders, and toads already spend much of their time underground in burrows, or they may seek refuge under logs or rocks during fire events. Using prescribed fire, managers can alter plant community composition and structure to restore or maintain habitat for focal species. But it's important that managers understand the natural history of focal species before implementing prescribed fire. How frequently fire is applied and during what season can have drastic effects on the plants that provide food and cover for target wildlife. Whatever combination of fire frequency and season of burn is used will benefit some wildlife species, but concurrently will reduce habitat quality for other wildlife. Some general benefits of fire include the germination of herbaceous plants, specifically legumes and grasses. There is more browse nutrition available, and this new growth is more palatable. There is an increase in fruits and seeds available in the 2 to 5 years after a fire, and a flourishing herbaceous layer becomes available for nesting and brood cover. The benefits of prescribed fire don't come from a one-time use. How often fire is applied, termed fire frequency or return interval, has a strong effect on plant community composition and structure. Shorter burn intervals are more effective at reducing the number and size of woody plants. Frequent burning reduces the amount of fuel that accumulates between fires. As a result, prescribed fires that are applied at a high frequency usually are low severity and have patchy coverage. These frequent fires favor herbaceous over woody plants or favor individual plant species with unique fire adaptations, such as the grass stage of the longleaf pines. A short burn interval of 1 to 3 years favors grasses and forbs under an open canopy, which in turn favors wildlife associated with a lush herbaceous layer, including Bachman sparrow and northern bobwhite. A longer burn interval of 3 to 5 years will favor persistence of woody sprouts and shrubs in the understory, which provides browse for white-tailed deer and nesting cover for wild turkey. Even less frequent fires, if low intensity, will allow hardwood species to achieve greater diameter and heights, in turn making them more difficult to manage with prescribed fire. These less frequent fires maintain a more dense midstory that may favor some mid-story nesting bird species. Burning at different times of the year, often referred to as different seasons, will influence the plant community in different ways. Prescribed fire applied during the leaf-off or dormant season are less damaging to woody plants because their reserves are below ground. Similar to less frequent burns, dormant season burning maintains a more substantial woody component in the understory. Shrubs and sprouts provide nest sites for shrub nesting songbirds. Conversely, fire applied during the growing season, typically from April to October, can severely damage or kill woody understory plants because their reserves are largely above ground during this period of the year. Hence, growing season burns favor herbaceous grasses and forbs, sparse shrub cover, and very little midstory. These conditions favor Bachman's sparrow, fox squirrels, and a variety of pollinating insects. Because of the drier understory fuels and higher temperatures that exist during the growing season, fires during this time tend to be hotter compared to dormant season burns. These hotter fires result in better control of hardwoods, which have thinner bark and are therefore more susceptible to being consumed by fire. The hotter a growing season fire is, the more likely the fire is to kill larger hardwood trees and other woody underbrush. Land managers may be concerned that early, growing season prescribed fire has greater potential to harm wildlife than burning during the dormant season. Deer fawns and other mammalian offspring, nests and broods of ground nesting birds, and rare butterflies are all susceptible to fires applied during the spring months. Although individual animal deaths or nest destruction from fire have been documented, the evidence for population-level effects on wildlife is weak. Furthermore, improved habitat quality in the subsequent years after fire offers critical nesting and brood cover. Whereas there always is a risk of fire-caused mortality of individual animals, conservation is best practiced with emphasis on the population-level effects over the long term. So even if a small number of animals perish in a growing season fire, the effective burning at that time will be more beneficial to the population's survival in the long run. Overall, the most appropriate fire regime for any ecosystem will depend on the management objectives and the characteristics of the individual system.